Hello friends, so today we can discuss this problem from the latest Codeforces round 643 Division 2 Problem D Game with Array. So Pitya and Vasya are competing with each other in a new interesting game as they always do. Okay. So in the beginning of the game, Pitya has come up with an array n of positive integers. Okay, so there's an array of length n of positive integers and sum of all the elements in his array should be equal to s. Okay, so you have to find out an array in which the sum of all the elements is equal to s, and then Pitya has to select an integer k which is between 0 and s. Okay, in order to win, Vasya has to find a non-empty sub-array in Pitya's array such that the sum of all the selected elements equal to either k or s minus k. Otherwise, Vasya lost. So Pitya has to first form an like array of size n whose sum of all the elements is s, and then also Pitya has to select an integer k. And if Vasya can find out any non-empty subarray in this vector such that the sum of it is either k or s minus k, then Vasya wins or else Vasya lost. So you have given n and s, you have to determine if Pitya wins or Vasya wins. So you have to find out whether if Pitya wins, print yes, print the what is the array and what is the k. So if the size of the array should be 1 and the total length is, the total sum of all the elements is 4, then the answer is 4 and k equal to 2. So you cannot find a sub array of size 2 in this. Okay, so in this Pitya wins. But as you can see, if there is a sub array of size 3 and 4, so if you take 3 length of size 3 and the total should be 4, the possible can be 1 1 2 or any iteration of it, because you can either do 2 1 1 such that the total should be equal to 4 and the total length of the vector is 3. Now as you can see, you can make 1, you can make 2, you can make 3 and you can make 4. You can make every possible k possible. I hope you understand. So that's why for this scenario you cannot form any such vector. So let's find out for which scenarios you cannot find and for which scenarios you can find. Okay, so let's take 3 blanks now. If the sum is equal to, the sum cannot be less than the n, because you cannot fill the total size of 2 in 3 blanks. Okay, so the minimum is 1 1 1 and then you can form 1 2 3. So if n is equal to, let's say, 3 and the total sum is equal to 3, then this is not possible. Okay, now take total sum equal to 4 and try to fill it. This is the same case. If we take 1 1 2, now we can form 1. Now the total sum can, if k equal to 1 we can find out, k equal to 2 we can find out, k equal to 3 we can find out, k equal to 4 we can find out. So for n equal to 3 and s equal to 4 you cannot make this case. Okay, now for 5, let's try for 5. You can do 2 1 1, 2 2 1 or any iteration of it. Now I can make 1, I can make 2, I can make 3. Okay, but I cannot make 4. But in this case, if I do this 1 and this, you can make 2 3 4 5. So as you can see in this also, for s equal to 5 also there exists one case. Now come s equal to 6. So the case can be 2 2 2. In this, as you can see in this, you cannot find a subarray of size 1 or s minus 1. The total is 6 minus 1, which is 5. So you cannot find. I hope you understand. So this is the logic or observation you want to see, and we are getting our answers for n equal to 3 from if s is equal to 6, which is just twice, as you can see. And for more numbers, yeah, this condition will hold true, and you can find a way always uh, a series. So n, so the 2n should be greater than equal to, or the number, the total sum should be greater than equal to this value, then only our array can exist. So that's the condition you want to find out. Other than this, if the condition you want to find out, then you can, what you can do is you fill all the n minus 1 characters with 2 and the last character with the remaining total length. So if the total length is 8, you fill everything with 2 except the last one, and the total should be 8, so the last should be 6. Now you cannot make a subarray of k equal to 1,